Performing operations with complex numbers. Since I equals the square root of -1, we perform operations with complex numbers in much the same way as we do with radical expressions. If a radicand is a negative real number, we first write the radical in terms of I before performing any operations, which means the square root of -1 times the square root of -1 is equal to I times I, which is I squared, which equals -1. The incorrect way to write this would be to take the square root of -1 times the square root of -1, rewrite it as -1 times -1, which is the square root of 1, which equals 1. We are multiplying two terms that both started out as negative square roots, so you need to deal with the root first by rewriting it as I. What this means, if I have the square root of -9 times the square root of -4, the square root of -9 is actually 3i, and the square root of -4 is 2i. 3 times 2 is 6, I times I is I squared, which means my answer is -6. In this example, perform the indicated operations, simplify the result. In one parenthesis, I have 6 minus 5i, plus in my other parenthesis, 3 plus 2i. The parentheses are only grouping our two complex numbers together. We have an addition sign in the middle, which means I want to add 6 and 3, which gives us 9. Then I want to add -5i and 2i, which gives us -3i. My final answer is 9 minus 3i. When writing a complex number, we always want to write the result in the form of a plus bi, where the real number is written first and the imaginary number is written second. In this example, perform the indicated operations, simplify the result of, in one parenthesis, 2 minus 8i, minus, in the other parenthesis, 7 minus 5i. Again, our parentheses are there for grouping. However, the minus sign is going to change the sign of the numbers in the second parenthesis. So my problem becomes 2 minus 8i minus 7 plus 5i. Adding the real number portion, 2 minus 7 is -5. Then adding the imaginary portion, -8i plus 5i is -3i. So my final answer is -5 minus 3i. In this example, perform the indicated operations, simplify the result of 3i times 7i. Since we're multiplying, we want to start by multiplying 3 and 7, which gives us 21. Then we want to multiply I times I, which is I squared. We need to simplify this result because I squared is equal to -1. So this simplifies to 21 times -1, which equals -21. In this example, perform the indicated operations, simplify the result of the square root of -5 times the square root of -7. Our first step is to simplify our square roots. The square root of -5 is I times the square root of 5. I want to multiply that by the square root of -7 simplifies to I square root of 7. Now I can multiply I times I is I squared. The square root of 5 times the square root of 7 is the square root of 35. I squared really equals negative 1, so my final answer is negative square root of 35. In this example, perform the indicated operation, simplify the result of 5i parentheses 3 minus 2i. For this problem, I want to distribute. 5i times 3 is 15i, and then 5i times negative 2i is negative 10i squared. This equals 15i minus 10 times I squared, which is negative 1. I want to write this in the form of a plus bi. Since my 15i is the imaginary number, I want to write it second. Minus 10 times negative 1 is a positive 10. 15i is positive, so I put plus 15i. The final answer is 10 plus 15i. In this example, perform the indicated operations, simplify the result. In one parenthesis, we have 5 plus 2i, in the other parenthesis, 6 minus 3i. We want to use FOIL to solve this. 5 times 6 gives me 30. 5 times negative 3i is negative 15i. 2i times 6 is a positive 12i, and 2i times negative 3i is negative 6i squared. Because I squared is equal to negative 1, when I have negative 6i squared, that is the same as negative 6 times negative 1, which is a positive 6. So instead of this first step, you may want to go straight to 30 minus 15i plus 12i plus 6. Adding my real numbers, 30 plus 6 is 36. Adding my imaginary numbers, negative 15i plus 12i is negative 3i. My final answer, 36 minus 3i. In this example, perform the indicated operations and simplify the result. Parentheses 6 plus 2i squared. Remember, when we have a parenthesis squared, that's really a parenthesis times a parenthesis. So this equals 6 plus 2i times 6 plus 2i. Times 6 is 36. 6 times 2i is a positive 12i. 2i times 6 is a positive 12i. And 2i times 2i is a negative 4. Remember, 2i times 2i would equal 4i squared. I squared is the same as negative 1, so 4 times negative 1 would give me negative 4. Adding our real numbers, 36 minus 4 is 32. Adding our imaginary numbers, 12i plus 12i is a positive 24i. Remember, the order of the numbers is important because standard form for a complex number is a plus bi, real number then imaginary number. Complex conjugate. Definition. The complex number a plus bi and a minus bi are called complex conjugates of each other. In this example, find the product of 5 plus 3i times 5 minus 3i. Using FOIL, this would equal 5 times 5, which is 25, 5 minus 3i, which is minus 15i, 3i times 5, which is a positive 15i, positive 3i times negative 3i, 3 times negative 3 is a negative 9, I times I is I squared, so that gives me a positive 9. Adding my real numbers, this would equal 25 plus 9 is 34, and then negative 15i plus 15i cancels completely. So my final answer is the real number 34. In this example, find the product of 2 minus 9i times 2 plus 9i. Again, using FOIL, 2 times 2 is 4. 2 times 9i is a positive 18i. Negative 9i times 2 is a negative 18i. Negative 9 times positive 9 is a negative 81. I times I is I squared, which is going to result in a positive 81. This equals 4 plus 81, which is 85. Then 18i minus 18i cancel, and my final answer is the real number 85. Dividing complex numbers. The product of any two complex conjugates is a real number. Simplify a quotient of two complex numbers by removing I from the denominator of the quotient. Since I is equal to the square root of negative 1, we have to eliminate any square roots from our denominator. To simplify the quotient of two complex numbers, we multiply the quotient by complex conjugate of the denominator divided by the complex conjugate of the denominator. This is very similar to how we rationalize the denominator when we have the square roots. In this example, simplify 7 divided by 8 plus 3i. If I multiply 8 plus 3i by its complex conjugate, it will result in a real number. So I want to multiply by 8 minus 3i. If I multiply the denominator by 8 minus 3i, I have to multiply the numerator by 8 minus 3i. So I am multiplying by the complex conjugate of the denominator divided by the complex conjugate of the denominator, which equals 1. This equals, I need to distribute my 7. 7 times 8 is 56, minus 7 times 3i is 21i. This is over 8 plus 3i times 8 minus 3i. 8 times 8 is 64. 8 times negative 3i is negative 24i. 3i times 8 is a positive 24i. And 3i times negative 3i is a negative 9i squared. Bringing over my numerator, 56 minus 21i divided by 64. Negative 24i plus 24i cancels, and negative 9i squared is the same as positive 9. Once you multiply by your complex conjugate, you may want to go straight to this step. Now I can add my real numbers in my denominator. So I have 56 minus 21i in the numerator, and that's divided by 64 plus 9 is 73. Because this fraction is not in the form of a plus bi, to rewrite your answer as 56 divided by 73 minus 21 divided by 73 with the I behind the fraction. 56 and 73 have nothing in common, so that fraction cannot be reduced. 21 and 73 have nothing in common, so that fraction cannot be reduced. In this example, simplify 2i divided by 4 minus I. Your first step is to multiply by the conjugate. The conjugate of 4 minus I is 4 plus I, so I want to multiply top and bottom by 4 plus I. For my numerator, I want to distribute. 2i times 4 is 8i, and 2i times I is a positive 2i squared. That's divided by 4 times 4 is 16. My middle terms will cancel. Negative I times positive I is negative I squared. So this equals 8i minus 2 over 16 plus 1, which equals, starting with my real number, negative 2 plus 8i divided by 17. Writing this in the form of a plus bi, I would have negative 2 over 17 plus 8 over 17i. Neither fraction reduces, so this is my final answer. In this example, simplify 2 plus 5i divided by 4 minus 3i. The conjugate of 4 minus 3i is 4 plus 3i. So I want to multiply my numerator and my denominator by 4 plus 3i. This will equal, using FOIL, 2 times 4 is 8. 2 times 3i is a positive 6i. 5i times 4 is a positive 20i. And 5i times 3i is a negative 15. All over, using FOIL again, 4 times 4 is 16. Since I'm using the conjugate, I know my middle terms will cancel. Negative 3i times a positive 3i is a positive 9. So this equals, starting with my real number, 8 minus 15 is a negative 7. Then my imaginary, 6 plus 20 is 26, so this is a positive 26i, all over 25. Writing it in standard form, I have negative 7 divided by 25 plus 26 divided by 25i. Neither fraction reduces, so this is my final answer. Dividing complex numbers. When the denominator of a fraction is a pure imaginary number, the easiest way to remove I from the denominator is to multiply the fraction by I over I. In this example, simplify 3 divided by 4i. Since it's pure imaginary, I'm going to multiply by I divided by I, which equals 3 times I is 3i, divided by 4i times I is 4i squared, which means I have 3i divided by negative 4. I can also write this answer as negative 3/4 I. Performing operations with complex numbers. When adding or subtracting complex numbers, add or subtract the real portion, then add or subtract the imaginary portion. All results are written in the form of a plus bi. Dividing complex numbers. If your denominator is a pure imaginary number, multiply the fraction by I divided by I. If your denominator is in the form of a plus bi, then multiply by the conjugate.